outs, I guess, of SQL and Postgres. This will be like more valuable. Give me a sec. This will be like it's useful for one, I think your externships, and then two for like leak code and things like that. Like these details are like people can be very kind of finicky about just getting every last detail of SQL right. So it's good to practice it, especially for interviews. So to get set up for this lesson, the first thing is it's with Postgres, right? So you cannot just use like Colab because Colab is in Google Cloud, and they don't just give you like the Postgres database up and running. So what you'll have to do is to get set up is to like we have this Pagilla data repository that I linked to. You just have to clone this down. So you do like git clone, right, Pagilla, or this link. All right. So we can just copy this, and then it'll be like git clone this link, right? And then that will clone down a folder called Pagilla. And now you can basically, if you cd into Pagilla, I think you may already have this database on your computer, by the way. I can't remember. But if you want to get it set up, basically what you need to do is connect to Postgres. And then, I already obviously have it probably set up a few times. But let's just say create a new database called like Pagilla lecture. All right. So first step is I'll create a database. Then I'll quit. And now I want to, just like before with our Foursquare, we want to essentially like create the schema. So for that, there's a file called Pagilla schema. All right. So now how do I run this against my new Pagilla lecture database? So it's PSQL-D for the database, and that's Pagilla lecture. And then I want to run the file Pagilla schema against it. Right? And now this will create do the create tables essentially. So I run this. You can see it's creating the indexes, creating the tables, altering whatever. If you want to like confirm that this is working, we can connect to the database at this point, and then just use /gt. And you can see these are the databases created, but if you like select, from actor, there's nothing in them. There's no data. So the next step we need to do is, I think it's just Pagilla data. I specified in the reading. Let's go back to it. I say, hey, not this one. Anyway, in this one, I say run this Pagilla schema and then run Pagilla data.sql. So let's do that. So PSQL-D run against this database Pagilla data, right? This SQL file. And this will be like our insert into. And you run all this. And now if we connect to our database this time, and here's our tables /dt for the tables. And now we do select all from actor.
Jeff, are you sharing different screen?
Do you see my terminal?
I think that there's a delay again.
Oh, there's just a delay, I suppose.
I see Colab. I've been working.
Yeah, we're not seeing the terminal. We're seeing
Oh, you
Colab,
don't see the terminal? Oh, sorry.
which was changing.
Now do you see the terminal?
Nothing there.
How about now? Now?
No, not yet. Yeah, no,
There it is.
yeah.
Oh, there it is. Okay. Thanks for pointing that out. So what I did before was I just I ran this command. Basically run the Pagilla data SQL file against the database Pagilla lecture, right? So the PSQL-D specifies the database, the -F specifies the file, and this Pagilla data.sql file, this inserts the data. Okay. And then previously what I did was I just did the same command, but first I ran Pagilla schema to create the tables. So first create all the tables, then insert the data. And now you can see we have some actual data in our database. So the next thing, and this is useful to know, is like to interact. You can interact. You try this stuff out directly in the from Postgres. That's fine with me. But if you want to do it through here, through the terminal, sorry, through Jupyter, what I'm doing is you can see I use this create engine command that comes from SQL Alchemy, which is a kind of like a SQL Python library. It basically has a little ORM. Maybe it's still lagging. And then this is the string. So here you specify the name of the database, PostgreSQL, and then we have the username. So the username for me is Postgres. If you don't have a username, I'll show you in a second how you can just delete this. And then I have colon, the password, right? And this is like a pretty typical pattern. And then the @ is the host. Oh no. So the host is specifying like where, like here it's localhost, but it could be like on an AWS machine. It's the IP address or it's localhost. So here it's localhost, and then finally / the database name. So the database name I think I used was Pagilla Lecture. So I could change that, for example, to Pagilla Lecture here. And now I do the connection, and now here I can just check that it is connected to my database, right? And I'm using the pd.readsql because it's just like a little bit nicer to view. And I just pass through the connection that comes from here.
Is this going to be in the Colab?
You cannot use this in Colab because, right? You can't connect to localhost from Colab because Colab's on Google's. It's on like the internet, and so it doesn't know about your laptop.
What are you running in?
Okay, so I'm running it in Jupyter Lab. So if I can just do Jupyter Space Lab and boot this up. And I think to install Jupyter on your terminal, you just do pip3 install Jupyter. You could also just take these commands and literally just copy them into Postgres, right? And you'll also be able to go through Postgres really without a problem. So what I want to go through in Postgres is essentially like, and I think the main way is just think of it as data types. Like we're learning a couple of new things about each data type. So if I do like select all from customer, limit 2. All right, let me make this a little bigger. Let's do select all from customer, limit 1, right? And then let's maybe just focus on, what should we do first? I guess we'll slice. So we'll focus on the first name. So do first name. So these are all string commands, okay? And we'll do limit like 5. So now what we can do is we'll work on like slicing a string. So for slicing in Postgres, you can do like left. I'll just show you how to do this. It's first name and then 3. And this will take the first 3 characters on the left. So it'll be like, or another way of thinking it is take the left 3 characters from this string, from this column, okay? So you see that? So again, like this is kind of a way to start cleaning your data in Postgres. So this is one new command, right? We saw how to do this with strings, and now you can see how to do this in Postgres with strings.
Jeff, how did you run Jupyter on your laptop? Can you show
So
me?
you can, sure. So you can close this down, and then you probably do pip3 install. I think it's just pip3 install Jupyter. And then from there, you can run the command Jupyter Space Lab.
Okay, thanks.
And you just want to make sure you're in the folder that has, right, the necessary, like the repository. So this has my IPYNB files, and that should boot it up for you. So there's a left command, right? It slices the characters from the left. There's also a right command. This will give you 3 characters from the right. Okay, so you can see that, right? So this is like fairly straightforward, but we have to go through it. The other thing you can do is combine stuff. So here we have the first name. If you want to combine, and we have the last name. So if you want to combine these, you can use the concat, and it'll be concat. We can just, this concat takes, I think, as many arguments as you want. So you can see this is doing it without a space in between, just literally sticking these two things together. But you can also put a space in between these two. So just do quotation mark space, and now this is a little bit better. Okay. And then finally, I think more often what you'll see is instead of people using the concat function, what you'll see more often is people use a double pipe. So it works the same way, essentially, as concat. If I do two pipes, this will just stick them together. See that? And then really what you'll generally do is do a space. So I'll do a space and then another set of two pipes. And now this is a little bit better. Yeah, there is no, it's like, what is the column here? We can give it a column name just by saying first name, last name, you know, as full name to make it a little bit better. All right. So a lot of this stuff is like, start Googling, I guess, like how to format, you know, your Postgres data as well. So we saw, okay, how to like slice data. We saw how to combine data, just like join essentially in Python. Let's look at some of the addresses. Sorry, select, is it not address? It is select address from, customer.address. No, maybe there's an address table. Let's just select start from address. Okay, so we have this address data, and it has this column called address on it. So let's just start by pulling that data. So we'll pull select address.address from the address table, which is a little confusing, but it's what we got. So now let's say we just want the this middle data, right? Like we have the numbers, maybe we need to pull this data and format it or pull it into like some sort of library to do some geolocation. What you can do is you can split apart this data by using, it's actually called split part, okay? So we'll do the name of the column that we're splitting, what we're splitting on, so we're splitting on a space here, and then which of these elements we want. So you can imagine this splits up this row into 3 elements, right? 1, 2, and 3, and we want the second one. And now we get the second one. So one thing that's kind of confusing is that Postgres is pretty unique in the fact that it starts at index 0, and it starts at index 1 instead of index 0. All right, so this is, 1, 2. All right, and then from there, of course, you could rejoin it by using the concat or the double pipe. So that's essentially it for, for string stuff. Just for just like some simple like numeric stuff to go through. This is very straightforward, I believe. So we do rental rate from film, limit like 3. Right, so this is some data. If say you want to like, let's do limit 10. Say we want to like round this data, you can just put the round here, and now you want to say the number of digits that you'd like to round to. So for example, if I want to round to 1, or I think it's like better, the number of decimal points. If I want to round to 1 decimal point, I'll put the number 1 here. Oh, yeah, and you see that? 1.0, 5.0. These are all rounding up, okay? You want to round to 2 decimal points. That's more similar to what we had. So now everything is back there. And then you could round, you could round to 0. I think it's basically the same thing because so we can, I guess this is 0 decimal points as well, right? So this is just formatting. If you want to round to like 5 decimal points, you could do that too. All right, so pretty simple. Casting is actually very valuable. So let me just show you that. Casting is like, let's do this. Select title and rental rate from film limit 3. Oops, I should spell this right. Okay, so this is like a decimal. This is of type decimal. If we want to change it to type like integer, you just do double colon integer. All right, and now you can see we changed everything to an integer. So changing something to the right type is super valuable. Another example of that, if I can find I have to take it from the lab. Lots of times you'll get like a string, and you'll want to turn it into, for instance, like a date time or a number. So I think I have this here. I just need to find the example. A note on casting. Okay, I just do it this way. So here you take a string and we turn it into a date. So you can see I just have this string. This is a string, and I just do the colon date. And as long as it's in the right format, it doesn't print it out. Sorry, it doesn't. Here it would, if I was connected.
I think you did a colon.
Oh, thanks. Thank you. Appreciate it. So this is converting it to a date. All right. So if you have data as like something that's a string, it's the same rule as in Python, that oftentimes we want to change it into a richer data type. So for example, here, string to date, oftentimes it might be string to numeric, right? And you just want to convert it. And a reason why something like that is valuable is, let's look at customer again. Select all from customer. Say like limit 3. Once we have, let's focus in on the, you can see this create date. Let's do that. Select create, I think it's just create date. Is that it? Yeah. All right. So you can do something like select extract, month from create date. So once we have this in a date format, Postgres knows how to figure out which month this is. And so it pulls that out. You can also do something like extract day of week from create date. So it knows that this day, February the 14th, was a Monday. Or I'm guessing it may be a Sunday. Probably a Sunday, 2022. So why is something like this very valuable? Say you want to do like prediction data, like for a store. And you want to say like, how many people do I think are going to come into this store? Just feeding this into like doing analysis on, it's February the 14th. Oftentimes that's not, given a random day, that's not super helpful. But saying this is a Monday, well, Mondays typically get this amount of traffic. This is a February day, that gets typically X amount of traffic, right? Like this is, et cetera, et cetera. It's this year versus that year, right? Like you can build a prediction model by splitting apart the information in a date. And so by doing extract day of week, extract month, extract year, that's the kind of information you often want to feed into an ML model, or just do some analytics. Just plot, sales versus month, sales versus day of the week, etc. Questions about this? It's more just like details. I think of like Postgres and knowing this types of thing, this exists, and also being able to read this code. So I'll deploy this if there are no other questions, and I'll deploy one more. So I'll deploy this reading in a lab, and then one more reading in lab. I feel like you all can handle it, but I'm happy to review it. Okay, all right. Something a little easier than working through 1,000 lines of code, I think.